Hello and welcome to Deeksha Karnataka YouTube channel and in the Masterstroke series of PU1. Today I am going to discuss two very important chapters, motion in a plane and Newton's laws of motion. From each chapters you can expect two questions, not one question, two questions each. So let us see what we are going to discuss in today's lecture. We are going to discuss in motion in a plane. We will be discussing scalars and vectors, everything included in this chapter. Projectile motion, very important concept. We will also briefly discuss about centripetal acceleration. In the motion, this is not motion in a straight line. This is Newton's laws of motion. Okay, so this is laws of motion, and here we are going to discuss laws of motion, three laws of motion, friction, and a very interesting important concept is lift motion. So lift motion, that is very crucial. I will be giving you some tips on how to solve certain kind of problems based on this, so don't forget to check that. And with this, let us start with the chapter of motion in a plane first. So first, obviously, is velocity, speed and acceleration. So these are the three quantities that you must know. So the instantaneous velocity is given by dx by dt. Obviously, how fast an object is moving with respect to time is velocity. Okay, time rate of change of displacement is also called velocity. But when it comes to instantaneous velocity, it depends on how fast the object is moving over a given period of time. That is called instantaneous velocity, and it is given by dx by dt. Now if you are given a displacement time graph, okay, x versus time graph, okay, this is the graph, then dx dt basically represents, let me change the color. So basically dx by dt gives you the slope of the graph. Okay, so this is dx, this is dt, and dx by dt basically gives you the slope of the graph. So at a certain point of time, if you know the slope, you know the instantaneous velocity. Slope of the displacement time graph at any given instant gives you the instantaneous velocity. Instantaneous acceleration is rate of change of velocity. So basically, in other words, you can say that this is nothing but, this is equals to double derivative of displacement. Okay, so d2x dt square. So if you, similar way, if your velocity time graph is given, slope of a velocity time graph gives you acceleration, and average velocity is very common, total distance traveled by total time taken. Right, now let's move on. Few graphs that you have to remember, because the graphs are very common and many times graphs are asked in the exam. So xt graph, xt is displacement time graph. The slope of displacement time graphs gives the instantaneous velocity. Velocity time graph, area under velocity time graph represents the total distance traveled, and slope of velocity time graph gives you the acceleration. So as I mentioned, okay, now area under the xt graph does not gives you anything. Vt graph, area under the graph means what is, suppose this is velocity, this is time, so this represents area under the graph. Okay, we have applied that in your P1. If you remember, different expressions for velocity, then total distance traveled, we calculated using this graph. Okay, and one aspect of the derivation was that area under the graph gives you the displacement, right? Or total distance traveled. Now in case of speed time graph, it is total distance traveled. In case of velocity time graph, it is the displacement. Okay, slope of velocity time graph gives the acceleration. Now acceleration time graph, area under acceleration time graph represents the change in velocity. This is very important. So change in velocity is given by area under acceleration time graph. Now there are three different graphs for a position time graph. Okay, first of all, when acceleration is positive, acceleration is negative, acceleration equals to 0. So these are the three graphs which represents three different cases. These cases are very important. So for positive acceleration, when the acceleration is increasing with time, the xt graph will be increasing as well. Okay, it can be, it not necessarily like that, it can be like that as well. Okay, the graph should be curved and it should increase with time. Okay, it should increase with time so that you can calculate the exact slope. If you can calculate the slope, you can calculate the velocity and correspondingly acceleration as well. Negative acceleration, the displacement decreases with time. Okay, and if it is a straight line, graph, acceleration is 0. And if it is a constant velocity, if the object is at rest, then this will be the graph straight. Okay, it will be parallel to time axis. If the graph is parallel to time axis, velocity equals to 0. Constant velocity, it will be a straight line graph. Okay, now when the object, if you drop an object at some height, okay, and if only force due to gravity is acting on the object, then it is said that object is at free falling state. Okay, or it is a free fall. Free fall means object is falling under the influence of gravity. That motion is called free fall. And in case of free fall, if you plot the graph of velocity versus time, then the graph will be like this. Now, why this is a negative graph, why the line is negative? Okay, because as the velocity object is falling downward, okay, its velocity in the downward direction increases. So downward direction means the distance from the surface of the earth is decreasing. That's why it considered as negative direction. Okay, anything which is falling towards earth is negative, anything which is going upward is considered positive. Similarly, the distance traveled with respect to time is actually like this. Okay, and it is slowly starting from some height and going towards 0. Okay, ignore this. So it will be having some positive value and slowly it will going towards 0. This might be true when the object is going into the surface of the earth. Okay, so zero surface is the earth surface, and if the object is going into the surface, inside the surface, suppose you dropped some stone inside say a mine. Okay, there is an open mine, you drop an object, or a well. Okay, well, you have seen well, okay, water wells. So if you drop a stone inside a well, this graph will be like this. Okay, the distance will be negative inside the surface of the earth, right? So this is the general graph for displacement. This is general graph for velocity for free fall. Okay, now equation of motion, very important. There are few equations of motion that you need to remember. Obviously very common. We are using all equations of motion in multiple times. So V equals to U plus AT. V is velocity, U is initial velocity, A is acceleration, T is time. S equals to ut plus half at square. This is also very common equation. S is the displacement, U is initial velocity, A is acceleration, T is time. Okay, and V square equals to U square plus 2AS. Now all these three equations are interlinked. Okay, interlinked means you can use one equation to go back to any other equation. So basically these three equations are not very independent. You can go from one equation to another very easily. But why do we need three equations? Based on what are the values that is given to you and what are the values that you want to calculate. So based on that, you can use any one of the three equation of motion. Out of that, this is considered to be most fundamental. Okay, this equation, and other equations can be proved from this equation, right? Now distance traveled in nth second, this can be sometimes handy if you know. If you don't know, does not worry, you don't need to remember this or memorize this formula. So distance traveled in nth second is nothing but suppose total distance traveled in n minus 1 second and distance traveled in total distance traveled in nth second. This is called distance traveled in exact nth second. Okay, that means suppose you are moving in a car. Okay, you are moving in a car exactly in the 10th second. 10th second means that 1 second. between 9 and 2:10, that exactly 1 second how much distance you have traveled. To calculate that, we generally use this formula. Okay, so this is the formula to calculate the distance traveled in nth second. You use these formulas for n and n minus 1 and then find the difference between them. That will give you the exact distance traveled in the nth second. Okay, so this is a shortcut formula. Sometimes it can be handy to save some time. That's it. But mostly this formula came in JEE. In KCET, I think only once if you had used this formula would have been some time saving for you. Otherwise, not super important. As I mentioned, this formula is obviously, these two formulas are obviously important, and based on what values are given to you and what you are trying to calculate, you need to use the exact formula. Let's see one question from 2025. Two stones being fall from rest from the same height with the second stone starting to fall at delta t seconds after the first falls from the rest. Okay, the distance of the separation between the two stones becomes capital H t naught seconds after the first stone starts its motion. Then t naught is equal to, so this is slight printing error, this is t naught. Okay, this is t naught, not to. Okay, so two stones being fall from the rest at the same height. So we have, suppose a tall building. Okay, we drop one stone from the rest. Okay, first stone was allowed to fall. Okay, and after delta t seconds, you allowed the second stone to fall from the same height. Okay, first stone already started to fall, and after delta t seconds you allowed the second stone to fall. Okay, now it says that after some time t naught, okay, after some time t naught, after the first stone starts, so after t naught of the first stone, okay, the height that these two stones have achieved, say, is capital H. Okay, now they asked you what is the value of t naught. Okay, so obviously when you drop the first stone, it started from the rest. So what is the total height or total distance traveled by the first stone? Say H1. Total distance traveled by the first stone, H1, is given by half g t naught square. Okay, this is the total distance traveled by the first stone. Now what about the second stone? Second stone covered, say this height is say H1, this height say H2. Second stone actually started to fall after delta t second. Okay, so the same formula will be same, only here it will be t naught minus delta t whole square. Okay, only this will be the difference. Why? Because obviously the second stone started delta t seconds after the first stone. Equation of motion, first equation is obviously very simple because the time t naught is given in terms of first stone. So first stone is, total time is t naught. For the second stone, because the second stone starts after delta t seconds, the time will be t naught minus delta t for the second stone. So in the question it is given that H is actually H1 minus H2. H is equals to H1 minus H2. So this value is given in the question, and from there you are supposed to calculate this t naught value. Okay, so now let's start. So H equals to, obviously half g will be common, so half g, that is g by 2, it is common, and in bracket we can write t naught square minus t naught minus delta t whole square, right? Now we have to simplify. So 2h by g equals to t naught square, that is a square minus b square. We can apply that, a plus b. So a plus b is t naught plus t naught minus delta t into T naught minus T naught plus delta T, right? So obviously T naught cancels, and you can write this as 2 T naught minus delta T into delta T, okay? Or you can write this as 2H by G into delta T equals to 2 T naught minus delta T. Now obviously T naught is much larger than delta T is very small time, so you can ignore this delta T. With respect to T naught, delta T is very small, so you can ignore this delta T and you can write 2 T naught equals to 2H by G into delta T, or 2 cancels and you can say T naught equals to H by G delta T. So correct answer is option D, okay, H by G delta T. So this is the correct answer. So obviously not super simple, not super difficult as well. So if you know the formula, how to solve it, do step by step method, and at the end just ignore this term because delta T is obviously, because it's a small distance, it is denoted by delta T. If it is a very large distance, it does not make any sense, the problem does not make any sense, okay? So obviously delta T you can ignore, right? So this is the end of the second chapter. Now let's move on to the third chapter, motion in a plane. So first concept that we are going to discuss in the third chapter, which is scalars and vectors. So a scalar quantity is a quantity with magnitude only. Scalar quantity is a quantity which only have magnitude but do not have any proper direction. Okay, it is specified completely by a single number along with the proper unit. The rules for combining scalars are the rules of the ordinary algebra. For example, mass, okay, 2 kg mass. Mass does not have any direction. If you want to add 2 kg mass with another 2 kg mass, you just need to add them. 2 plus 2 equals to 4. So that is simple addition method. So for any scalar, you just need to know the value and you can simply add them algebraically. Now not always it will be positive. For example, plus 2 coulomb charge and minus 1 coulomb charge, if you add them, you will get 1 coulomb charge only. So sometimes plus and minus is possible, okay? Displacement, for example, distance traveled, okay? Suppose distance traveled is a scalar quantity. If you travel 2 km and then another 2 km, it will be added. 4 km is the total distance travel, independent of the direction. Similarly, there is one more quantity which depends not only on value but also on direction. That quantity is called vector quantity. So vector quantity is a quantity that has both magnitude and direction and obeys triangle law or equivalently the parallelogram law of addition. So when you are trying to add two quantities and you are not always getting exactly 2 plus 2 equals to 4 is not happening, then you will say this must be a vector quantity. So 2 plus 2 is not always equals to 4. It depends on whether the quantity have a direction or not, and if they have direction, whether they are in the same direction or not. For example, if you travel 2 km in the east and then 2 km in the north, your displacement will be 2 into root 2 km in the east north direction. Okay, so 2 km in the east, okay, and 2 km in the north. Suppose this is how you traveled. Now what is your displacement? Your displacement will be in the northeast direction and it will be 2 root 2 km. It is not 4 km. Okay, so 2 plus 2 is not always 4. So here we are using triangle law of addition. You can use parallelogram law of addition as well. Now before going into that, we have to know something very important, which is called resolution of a vector. Resolution means, what is the meaning of resolution? Not New Year resolution. Resolution means dividing. Okay, dividing. So basically where we have a vector, suppose we have a vector, say A vector. it is completely given like this. We have no idea what is the exact position, and based on the question, based on the situation, we resolve this vector into two perpendicular vectors. How to do that? We consider now these axes that we are going to discuss about resolution. It can be based on the question. It can be any two perpendicular vectors can be considered for this. We are generally we will like to do it in terms of our known coordinate system, x and y axis. So we will take one component along the x direction. Okay. Just a second. Suppose this is one direction, okay, and one another direction will be okay. This is one direction. Now next is, suppose we are doing another in this direction, okay. So these are the two directions that we generally consider. One is, say, this is x, this is y, okay. So when one vector is given and we choose two perpendicular axes and we take the component of this vector along this axis, then they are called two components of the original vector. So how to take the component? For that we have to draw a perpendicular from here to here. This will give me the x component of the vector. We'll denote it by ax, and we take another perpendicular on the y axis, and this gives me the y coordinate. So this is ay. Okay, so ax and ay are the two components of the vector a. Now if this angle is denoted by theta, it can be any one of the angle. Now I will tell you the secret of that as well. So if you know the angle, one angle you know, then you can find the components as well. So the adjacent component means the component which is next to the angle. So here this theta is next to the x component. So ax will be the original vector into cos theta. Here a is the magnitude of the vector, obviously. Magnitude means only the length. So whenever we say that this is a vector a, okay, that means this length is called magnitude. This length is called magnitude, and this is the direction. Okay, this is the magnitude. The length denotes the magnitude, and the arrow denotes the direction. So here this is the length. So a cos theta is the x component. Why a cos theta? You can use geometry to find the projection of this. Okay, so if this is theta, then it will be x cos theta, and this will be a y component. So this will be a sin theta. Okay, if this is ay, this will also be ay, and if this is ax, this will also be ax. Just for your reference. Okay. Now remember that component which is adjacent is cos component, which is perpendicular is sine component, always. Now if instead of this, if this angle was given, suppose this angle was given as phi, so ay will be a cos phi, okay, and ax will be a sine phi. Okay, so does not matter which angle x, it will not necessarily only the angle with x axis will be given, but remember the component which is next to the angle will always be cos component, which is called adjacent component, and the component which is perpendicular to other component is called the perpendicular component. Adjacent component, perpendicular component. Okay, always remember that. Now let's move on. Dot product and cross product. So vector multiplication. Even though vector multiplication we deals with some other chapter, but because vector is introduced in this chapter, I like to complete entire vector in this chapter itself. So dot and cross product. So what is dot product? So when two vectors are given, okay, and you are multiplying them, the result turns out, the final result turns out to be a scalar. That is called a dot product or scalar product. Okay, based on different situation, while multiplying two vectors, we can get a scalar quantity, we can get a vector quantity as well. So if the final resultant is a scalar quantity, then it is called a dot product, and A dot B is given by AB cos theta. Obviously we know that, and A cross B is the cross product, it is given by AB sin theta n cap. N cap is a vector which is mutually perpendicular to both A vector and B vector. Now suppose this vector is A vector, this vector is B vector. Dot product is basically projection. Dot product is kind of projection. You are taking the projection of this vector on the other vector or this vector on the other vector. Okay, you have done this in mathematics. Okay, physical explanation of dot product and cross product. Okay, projection is basically dot product. Now what about cross product? Cross product is slightly tricky. Here the important part is how to find the direction of the resultant. Direction of the resultant is important. Suppose this is A, this is B. You want to find the resultant direction of the A cross B. So how to do that? Is A cross B, is it equal to B cross A? No. Okay, A dot B equals to B dot A, does not matter. Okay, because it's a projection and final result is scalar quantity. So in terms of dot product, it is commutative. So A dot B equals to B dot A, but A cross B is not equals to B cross A. Even though magnitudes are same, directions will be different. Now how to find the direction of two cross product? So first you point your fingers in the direction of the first vector. So A cross B, the order matters. First is A vector. So point your fingers in the direction of A vector. Curl your finger towards the second vector, then your thumb will give the direction of the resultant. Okay, so this is the result. So obviously it's out of the paper. So A cross B is out of the paper. Now if you do B cross A, so B is in this direction. Now if you do the B cross A, obviously it will be into the page of the paper. So A cross B is not equal to B cross A. In fact, A cross B equals to negative of B cross A. So A cross B is actually minus B cross A. Okay, vectors are same in magnitude but opposite in direction. Okay, remember that A cross B equals to minus B cross A. They are opposite in direction. So A cross B, B cross A are exactly opposite in direction. Now in many cases there might be cases where you have to find the direction of the two vectors when they are being cross product. So remember that, point your finger in one direction, curl the fingers in the second vector direction, then your thumb will give the direction of the cross product. Now there are some applications for cross product and dot product. If two vectors are given to you and if they ask that show that these vectors are perpendicular or find what is the angle between the vectors, generally we use dot product. Okay, dot product is basically to show that these two vectors are perpendicular. Okay, if two vectors are perpendicular, their dot product is 0. Okay, also if you want to find the angle between two vectors, you generally use the dot product rule. Cross product is basically when two vectors are parallel. If the vectors are parallel, their cross product is 0. So they will give you some vectors in terms of fundamental vectors of x, y, I cap, j cap and k cap. So if you go back to our previous slide, so this position vectors generally in 3 dimension, okay, x, y and z, okay, x, y and z. Okay, so the unit vectors are basically projection of one unit vector on x-axis. It is written by I cap. For y-axis it is written by j cap, and for z-axis it is written by k cap. In 3 dimension, I cap, j cap, k cap are called 3 unit vectors. Okay, these unit vectors can be used to represent any vectors. Any vector, for example, if I say A vector equals to 2 I cap minus 3 j cap plus 5 k cap. That means you go 2 units in the x direction minus 3 means in the negative y direction you go 3 units, and then positive x direction you go 5 units, then you will get this vector. Units means 1, okay, obviously 1 is generally defined. If you have drawn the graph in your class 10th graph equations in mathematics, there you have to define 1 unit. One smallest square in the graph paper is considered as 1 small unit, okay, based on you have done graphing in your experiment also. There also you have defined what is the 1 unit means, right? So see, this 1 unit will be obviously known, and then you can define any vector using resolution of vectors, okay. So basically if you given this vector, suppose this is vector A, okay, if you resolve this vector into x, y, z component, you will get this vector, okay. This is how you, basically this is the application of resolution, okay. So when two vectors will be given to you and say that these two vectors are perpendicular, find the unknown value. Suppose one vector is given, A vector equals to say A I cap plus 2 j cap, and B vector equals to say 3 I cap minus 4 k cap. Now it says that A and B are perpendicular. What is the value of A? So in that case, what you have to do? You have to do A dot B equals to 0. Okay, A dot B has to be 0 because they are perpendicular. If two vectors are perpendicular, their dot product is always 0. Now remember that I dot I equals to j dot j equals to k dot k equals to 1, and any other mix is 0. Any other mix, I dot j, I dot k or j dot k, they are 0, okay. So only when you are multiplying same vectors, same unit vectors, the value is 1, otherwise all mixed product is 0. So that means when you are doing dot product of A dot B, what you get? You can dot product only these two quantities. So 3 into A, 3A. Okay, these cross terms will be 0. Okay, so this cross term will be 0. Okay, so 3 into A minus JJ, so it will be minus 8. And because the dot product is 0 on the right hand side, it will be 0. So from here you can say A equals to 8 by 3. So based on the question, they will give you such unknown cases, and if they say that okay, these two vectors are perpendicular, okay, what is the unknown value? Then you just need to find the dot product, equate it to 0 and calculate it. Similarly, if vectors are parallel to each other, then you have to find the cross product. Now how to find cross product of two vectors? Okay, to find cross product of two vectors, you just need to just a second, let me add a page. Now to find the cross product, suppose we are doing A cross B, okay, and A is given by say AX I cap plus AY j cap plus AZ k cap. One of the component can be 0, okay, and suppose B vector is given by BX I cap, just a second, say BX I cap plus BY j cap plus BZ k cap. So how to find the cross product of A cross B? So in that case, you basically use determinant method, I cap, j cap, k cap, okay, AX, AY, AZ. Now you have used in mathematics, but you might be thinking, sir, that is a separate vector. Maybe mathematical vectors are different from physics vectors. No, they are not. Obviously, you can use this method, and same way you solve a determinant, you can simplify this determinant to calculate the cross product. Okay. Now, if it is a parallel vector, they will be 0, and from there you can say if x component is 0, y component will be 0. Individually, components will also be 0. One important thing is that in case of if when you calculate this vector, okay, individually all the components will be 0. So after calculating, I cap component will be 0, j cap component will be 0, k cap component will be 0. Okay, so remember that, right? Now let's move on to the next part where we are discussing vector addition. Now after multiplication we are coming back to addition. So when you add two vectors, say vector A and vector B, okay, they are making at some angle theta with them. How you can add these two vectors? So to add two vectors which are at an angle theta, the very simple formula is a square plus b square plus 2ab cos theta whole root. Okay, so this is the magnitude of the vector addition, magnitude of the vector addition. So this symbol obviously denotes the magnitude. So a plus b's magnitude is given by square root of a square plus b square plus 2ab cos theta. Sometimes this is represented as r. Okay, r is the resultant, or r square is equals to a square plus b square plus 2ab cos theta. Now in some cases, if theta equals to 90 degrees, just a special case, if theta equals to 90 degrees, then you can write this as r square equals to a square plus b square. Okay, obviously cos theta is 0. Simply you can write resultant is basically a square plus b square. So this is like a Pythagoras theorem. When two vectors are perpendicular, to calculate resultant you just need to use Pythagoras theorem. Okay. Now this is not over, you have to find the direction of this vector as well. Now if you are measuring the direction angle alpha with respect to say vector A, you can find this angle with respect to B also. Okay, but if you are measuring the angle alpha with respect to vector A, then it will be b sin theta by b cos theta plus A. Remember this. Okay, so this is the angle with which you are measuring. So A is alone. So how to find the angle alpha? So tan alpha, which side, with respect to which side you are measuring the angle? With respect to A you are measuring. What is the sign? Tan. Tan means what? Tan means sine by cos. So sine by cos. Okay. So obviously it will be in terms of theta. Theta is known, given in the problem. So tan alpha equals to b sin theta by b cos theta, and whatever side you are choosing with respect to which you are measuring the angle, that will be alone A. Okay. Just for your reference. Okay, the angle is not super important in KCET exam. Now, the one more important concept in this chapter is projectile motion. All the formulas are important, you have to memorize them. Okay, otherwise you will lose out on time, because if some question is coming, what is the time of flight? If you don't know the formula, you will lose out on time. Otherwise, one question you have to miss. Okay, so if you are someone, except maybe equation of projectile, other formulas all are maximum height, range of projectile, time of flight, these three formulas are super duper important. Generally you might see one question based on this formula. Out of these three formula, one question will come, and obviously projectile, the equation graph of projectile looks like this. Okay, and what is the projectile motion? Projectile motion is in the absence of any other force, only in the presence of gravity. When the object moves, it is basically traces a parabolic motion, and that path is called projectile motion. Okay, remember that there is no other force except gravity, not even the drag forces. Okay, even if there is a drag force, it will not be exactly parabola. So the path is parabola only when only gravity is acting on it. Okay, other than that, it will be not a perfect parabola. So time of flight 2 v naught sin theta by 2. Obviously theta is the angle of projection with which the projectile is projected. That angle is given by theta. Okay, maximum height is v naught sin theta whole square by 2g, and range of projectile is v naught square sin 2 theta by g. Obviously the derivations are not required, only values and final answers are required. Okay, you have done the derivations in your P1. No, you do not need to do the derivation once more, just the formulas are sufficient. range is maximum at theta equals to 45 degrees. Okay, so maximum range is when this projectile hits the maximum distance. Okay, so that is how a range of a projectile is determined. So if I say that BrahMos missile can hit a target at 100 kilometer distance, that means when it is launched at an angle of 45 degrees. Okay, so that's how we determine the range of a projectile. So range is maximum at an angle theta equals to 45 degrees. Now let's see one question, one type of question that is coming from this chapter, and then it will be we will conclude this session. A particle is projected with a velocity v so that it is horizontal range twice the greatest height attained. The horizontal range is. So particle is projected with a velocity v so that its horizontal range, okay, is twice the greatest height attained, and you have to find the horizontal range. You have to find the r. Now what is r? R is velocity, initial velocity is v, so v square sine 2 theta upon g. Okay, this is the range. As I mentioned, if you remember the formulas, it will be very, very helpful. Similarly, the height of the maximum height that projectile attains is given by v square sine square theta by 2g. Okay, v square sine square theta by 2g. Now we have to simplify. Obviously v square cancels. Okay, now you have to simplify. We basically we will just need to find this sine 2 theta value. Okay, if you can find sine 2 theta, that will be very easy, but obviously directly you cannot do that. G cancels, these two also cancel, so we get sine 2 theta equals to sine square theta. Okay, so if you can somehow find this value, it will be very, very helpful. Let's see that. So sine 2 theta means 2 sine theta cos theta equals to sine square theta. Okay, or obviously sine cancel, we get 2 cos theta equals to sine theta. Okay, and what is the horizontal range? By the way, horizontal range, as I mentioned, is basically v square sine 2 theta upon g. Now if you can find the value of sine 2 theta using these equations, then only you can say, okay, what is the value? Obviously it is not 45 degrees, so you cannot say this is the maximum value, but how can we calculate sine 2 theta using this relation? Let's see what we can do. So sine 2 theta 2 into sine theta cos theta. So obviously we can substitute, but here if you see the options, answer is independent of the theta. So we have to find and figure out the values of sine theta and cos theta. That is the major portion about this problem. Okay, now let's see. So from here we can find the tan theta. Obviously tan theta equals to 2. Sin theta by cos theta is tan theta. Now we are trying to find sin 2 theta. Forget about this. Okay, so sin 2 theta we are trying to find. Now we know that sin 2 theta obviously equals to 2 tan theta divided by 1 plus tan square theta. Right, this is an identity, so we will simply use that. So it will be 2 into 2 divided by 1 plus 4. Right, tan square theta means 2 square, so it will be 4 upon 5. Right, so sin 2 theta is 4 upon 5. So we can write this will be 4 v square by 5 g. Okay, so some trigonometry, some physics combined together, basically we are solving it. So problem is simple, this much is physics, after from here onwards is basically trigonometry. Okay, sine 2 theta is equal to 2 sine theta by 1 plus tan square theta. So if you put that value, you will get the value of resultant. So the horizontal range is 4 upon 5 v square by g, right? So this is the end of today's lecture. Okay, and obviously one more formula is there, centripetal acceleration. Centripetal acceleration is basically when an object is moving in a circular orbit. Okay, there is always an acceleration which is acting in towards the center, which is called centripetal acceleration, and it is given by v square by r. So v is the velocity and r is the radius of the rotation. So this happens only in the rotational motion. So when an object is rotating in a circular motion, there will always be an acceleration towards the center of the circular path, and that acceleration is called centripetal acceleration. Its value is v square by r. In our upcoming chapter, we will study about centripetal force and importance of it. Laws of motion. So let's start. Maximum acceleration of the train in which a 50 kg box lying on its floor will remain stationary given coefficient of static friction between the box and the train's floor is 0.3 and g is 10 meter per second square. So basically the question, if you read properly, it will say that there is a train. Okay, so we all know how the train looks like. So suppose this is a train. And there are some other bogies also. We are not interested in the design of the train. So here you kept a box. Okay, the frictional force between the floor and the box is 0.3 and gravitational acceleration is 10. Now it says that the maximum acceleration with which the train can accelerate so that the box remain stationary. Now how can the box remain stationary inside the train? Because there is a friction force. Friction force always acts in the direction opposite to that of the motion. So this is the force of friction. Okay, force of friction is acting opposite to the direction of motion, and the force acting on the train because of the acceleration which is given by F, these two forces has to be same. Okay, now what is force of friction? So if you draw the free body diagram of the box, so there is a friction force over here, there is a acceleration force over here. Due to acceleration force is very easy, which is equals to ma, right? Father equals to ma, that we all know. So from laws of motion, F is equal to ma is the force that is acting on an object which is accelerating. Now what is force of friction? For that, first of all, we need to find the weight of the body. Weight is given by mg, and normal reaction. Okay, normal reaction, because it's for this particular case the box is kept flat, so that means whatever is the weight, the normal reaction will be exactly equal, that is equals to mg. And remember, always force of friction is equals to mu r. Okay, mu r, and if the body is flat, it can be simply written as mu mg. If it is not flat, for example, we will come across such examples when the body is kept on an inclined plane. In that case, you have to add the component of the weight which is actually giving you the normal reaction force. The weight is acting downwards, normal reaction force is acting upward. I hope you have done this kind of problem in your PU1. If not, just remember that the downward force is basically given by mg, that is weight, and the normal reaction can change based on the situation to situation, but normal reaction is basically the Newton's third law, reactionary force which is acting on the object. Okay, based on this normal reaction, you can calculate this is the relationship between force of friction and normal reaction. Okay, now as I mentioned that if the object is stationary, then this force of friction must be equals to the force of acceleration, that is mu mg equals to ma. mm cancels. Okay, so acceleration is nothing but mu g, that is 0.3 into 10, that is 3 meter per second square. Now I explained this problem a lot, so if you start with the problem, just draw the free body diagram to understand the problem, then you can apply the formulas and directly solve it. Obviously you don't need to explain it to the examiner, you just need to find the answer. So correct answer is 3 meter per second square. Next question, a body of mass 50 kg is suspended using a spring balance inside a lift at rest. If the lift starts falling freely, then the reading of the spring balance. Now when you are inside a lift, we have done lift motion in detail during the theory lecture. Okay, so when the body is falling freely, that means the gravitational acceleration is downward g, so there will be no reaction force will be 0. So the spring balance, which actually measures the reaction force, will show you 0 reading. The reading of the spring balance will be 0 in case of free fall. In case of free fall, if you are standing inside the lift, you will feel no weight of you because the reaction force will be 0. Okay, you can go and check the theory lecture, there I have explained. So it will be because of free fall, the weight will be 0. It is called weightlessness. Next, a block rests on a rough inclined plane making an angle 30 degree with the horizontal. The coefficient of static friction between the block and the plate is 0.8. If the frictional force on the block is 10 Newton, the mass of the block is. So let's see. Here we have a rough inclined plane, okay, making an angle 30 degrees. Now the block is resting on the plane. Now inclined motion, whatever I am going to teach you right now, just remember it. It will be very, very beneficial if you see a question based on inclined plane. So the weight of the, now the body is not flat, okay, it is not lying flat horizontally, it is somewhat at an angle. So the weight always acts towards the center of the earth, right? Weights always acts on the center, towards the center of the earth. Okay, so it will always act downward direction. This is mg. Okay, now there will be two components of this weight. One component will be in this direction, okay, and one component will be in this direction. Now if this angle is theta, you can show that geometrically. Obviously we are not doing this. If this angle is theta, then this angle will also be theta, and being a adjacent component, this will be simply the cos theta component, that is mg cos theta, and this will be mg sin theta. The normal reaction force in this case will be R, which is equals to this value. Now remember that frictional force mu mg that we have written in the previous case, okay, remember that frictional force mu into R, this is the maximum frictional force. This is the maximum frictional force, especially for static friction. Okay, static friction is varying, it changes with the applied force. Okay, in maximum case this is the true formula, but otherwise this is not always attained. You can have a equilibrium, or the object is at rest even if the force is not maximum, as long as the applied force on the body is below this range, the frictional force will auto adjust. It's an auto adjustment force which will adjust itself such that this force is actually equals to applied force. Only if the maximum force downward is applied or more than maximum force is applied, then you have to cross this threshold. This is called the threshold force, threshold frictional force. Okay, so now here the frictional force is given 10 Newton, and a coefficient of friction is also given. So if frictional force is given, you can ignore the frictional coefficient of friction. You just need to say, okay, this is my frictional force or force of friction, that should be equals to force of friction is acting in this direction opposite to the motion, because the block is trying to slide down the incline, right? If you keep something on the incline, it will try to fall, right? So frictional force is acting in this direction, and the force which is trying to bring it down is mg sin theta. So this frictional force must be equals to mg sine theta, and you should not calculate this mu r and try to calculate mass. Okay, so here the main trick of this problem is that maximum frictional force is not attained. Okay, maximum frictional force will be much more than 10 Newton. So that's why how do I know that? Because here the frictional force is directly given, so you don't need to consider the coefficient of friction. Because F is given, F should be equals to mg sine theta. So just compare that. So F is 10 Newton, m we do not know, g is 10, sine theta here is sine 30, sine 30 is half. Okay, sine 30 is equals to half, right? Just calculate, 10 cancel, so m equals to 2 kg. Okay, cross multiply, m equals to 2 kg. So correct answer is 2 kg. Clear? Next, a man weighing 60 kg in a lift moving down with acceleration of 1.8 meter per second square. The force exerted by the floor on him. Okay, now lift motion, as I mentioned, so the man is standing on the lift. Okay, and the weight of the person, the mass of the person is 60 kg, and when the lift is moving down with an acceleration of 1.8 meter per second square. Okay, the mass is 60 kg, so here the weight is obviously mg, and here we also have a reactionary force. Now how to calculate that? Now with experience you will know if the lift is accelerating downward, okay, the reactionary force will be less. But if you are someone who want to do it from the basic, as I explained, the direction of acceleration is in the direction of mg, right? So mg is bigger quantity, it is rich, r is poor, so mg minus r, okay, rich minus poor equals to ma. Okay, always remember that whoever has the direction of acceleration, that quantity is rich. Okay, the other quantity which is going opposite to that, the direction of acceleration, that quantity is poor. So rich minus poor equals to ma. Okay, so what is mg? Mg is obviously we do not know. Well, let's simplify that. We are trying to find this r value. Okay, reactionary force, the force exerted by the floor on him, that is the reactionary force. So reactionary force r will be mg minus ma. Okay, you take this r on the other side, ma on this side, then rearrange it, or it will be mg minus a, or 60 into g is 9.8. Here we will take 9.8 because the acceleration here is given 1.8, so it will be easier for us to calculate. So r equals to, anyway that is more accurate, so it will be 8. So 8 means 48, 480 Newton. So the reactionary force is 480 Newton. Okay, you can start it directly from here. If you are confused, you can draw the free body diagram and then solve it. Okay, next question, an object with mass 5 kilogram is acted upon by a force of F is equal to this, and its initial velocity at t equals to 0 is this. The time at which it will just have a velocity along y-axis. I solved this question during the lecture, so you can check that out. As I mentioned, I will solve it again, don't worry. So here velocity has two components. This is x component, so vx equals to 6 and vy equals to minus 12. Similarly, the force also have two components, fx equals to minus 3 and fy equals to plus 4. Now it says that it will have only y component, not x component. That means the x component velocity is 0. Okay, let me just change it a little bit. Okay, let me just change it a little bit. Let me write it as ux and uy. Okay, initial generally denoted by u. Okay, so here it is ux and uy are given, so vx must be 0. So even though the problem says velocity along y-axis, actually it is a x-axis problem. So we have to find the velocity where Vx is 0. How to do that? For that we have to calculate the acceleration along x-axis. How to calculate acceleration along x-axis? To calculate acceleration along x-axis, you need to take the x component of force divided by its mass. Okay, Newton's laws are individually applicable to all the components, x component as well as y component. Okay, so it will be minus 3 divided by 5. Leave it here. Now what formula we will be using? We will be using the formula V is equal to U plus AT. So Vx equals to Ux plus Ax into T. V is equal to U plus AT, equation of motion, and that V should be equals to 0. So from here we can find the time, which will be minus Ux by Ax. Okay, or what is Ux? Ux is 6. Minus sign is there. Don't worry, minus sign will cancel. Minus 3 by 5. Remember, time cannot be negative. Whenever you are calculating some problem related to time cannot be negative. So 10. So it will be after 10 seconds the particle will have only its y component, x component is 0. Okay, now let's move on to the next question. One end of a string of length L is connected to a particle of mass m and the other to a small peg on a smooth horizontal table. If the particle moves in a circle with speed v, the net force on the particle directed towards the center is, so here we have a small peg of mass m, length L. Okay, it is tied to a string and it is rotating in a circle. It is rotating in a circular motion. Now whenever there is a circular motion, what we know that there is always a force which is acting on this, which is the centripetal force, which is mv square by L. Okay, this is the centripetal force. Now centripetal force is not something which is original. I mentioned it in the past as well. It is not a fundamental force. It has to be supplied by something. So which force here is supplying this force? So when the string is rotating, there is a tension built up on the string. That tension is actually providing the required centripetal force. Okay, some people accidentally use centrifugal force. Centrifugal force has no meaning unless you are sitting over here. So do not use centrifugal force. Centrifugal force is a pseudo force. It can be experienced only by people who is sitting inside this rotating object, right? You cannot feel it from outside. From outside, centripetal force is always there. Okay, so this tension is actually providing the required centripetal force. So either the answer will be T or it will be mv square by L. Okay, so the force towards the center. The force towards the center is either T or mv square by L. Neither subtraction, neither addition, nor 0. So here tension is given, so I will mark tension. If only mv square by L is given, mv square by L is also correct. Okay, remember that there is no addition or subtraction between centripetal force and tension. Never. Okay, so centripetal force itself tension, tension itself centripetal force, and there is no equilibrium here because the object is obviously moving. That means centripetal force has to be provided. Who is providing? It has to be provided by the tension. Next question: a coin placed on a rotating turntable just slips if it is placed at a distance of 4 cm from the center. If the angular velocity of the turntable is doubled, it will just slip at a distance of. Here again a question based on centripetal force. Okay, here we will use angular speed, not the linear speed. So suppose we kept a coin over here at a distance of 4 cm. And when the table is rotating, say with an angular speed omega, okay, the frictional force which is acting on this coin, which is sufficient, obviously frictional force is constant over here. Okay, the frictional force is actually providing the required centripetal force, and when the speed is equals to omega, the coin starts to slip. It will tend to move away so that it can adjust the required centripetal force. So that means at this point centripetal force is exactly equals to the frictional force. So frictional force equals to m omega square r. R is equals to 4 centimeter. Okay, initially. So this is the first case. Second case, when the you increase the speed to 2 omega. Now say that at a distance capital R, the coin starts to slip. Okay, and at a new distance of capital R, the coin starts to slip. Then what? Frictional force is same. Okay, the frictional force that is acting on the coin, because it depends on weight and the surface is same, weight is same, so coefficient of friction is same. So that means the force of friction is same. So that means we can write this as m 2 omega square r. Okay, these two forces has to be same. This is the new required centripetal force. This is the old centripetal force where it was slipping. This is the new centripetal force. So m cancels and we get omega square into 4 equals to 4 omega square into r. So omega square cancels. So r 4 and 4 cancels and we get r equals to 1 centimeter. Okay, so r will be 1 centimeter. Correct answer is 1 centimeter. Clear? Next, two masses of 5 kg and 3 kg are suspended with the help of massless inextensible strings as shown in the figure. When the whole system is going upwards with an acceleration of 2 meter per second square, the value of T1. So here the value of T1 we have to calculate. Two masses are tied like this and the whole system is accelerating with the speed of 2 meter per second square. Okay, so meter per second square. So whole system is accelerating with the 2 meter per second square. Now we have to calculate. Now there is a shortcut method, there is a long method. Okay, I will teach you the shortcut method because in the exam a lot of you are asking, sir, I need shortcut. So what is the shortcut? So when you see this kind of systems, okay, in KCET 2 object problems is maximum. 3 object problem I have not seen. Even 3 object problem, if they ask you to find the topmost 3 object problem, the middle one can be tricky. Otherwise, bottom one and top one, you can always use the method that I am teaching you right now. Okay, so if you are calculating the T1, that is the top force, do not consider them separate objects. You consider them as a single object. So this is 5 kg, this is 3 kg. What is the total mass? Total mass is 5 plus 3. Okay, that is 8 kg. Okay, so you can consider the total mass. Do not consider individually, that will take longer time. That will take even those who are coming from JEE, they may have solved this kind of problems using 3 body, especially 3 body problems. Okay, where 3 objects are tied like this. So but in simple cases like this, what you can do, you can simply add the masses. You can simply add 5 kg and 3 kg, 8 kg. Okay, and in future maybe I will give you more problems on this kind of situation so that you are prepared how to apply shortcut. So here you just need to add these two masses. Total mass is 8 kg. Okay, the tension should be T1, the entire object. Now you consider the one object problem. Now your problem becomes only one object having mass equals to 8 kg. Okay, the tension here is T1. Object is accelerating upward with acceleration say A, and what else is acting on this? The weight of the object, which is mg. Okay, now what is the direction of acceleration? Acceleration is upward. That means what? That means T1 is rich, mg is poor. T1 is rich, mg is poor. That means rich minus poor equals to ma. Rich minus poor equals to ma. Okay, so what is T1? We are trying to find T1. What is so it will be m into g plus a. Very simple. Okay, now here m is given by 8. we are using this value, not individually these values. Okay, 8 into A is what? G is 9.8 and this is 2, so it will be 11.8. Okay, 11.8. So if you take this value as 12, close to 10, okay, even though the question says 9.8, you are not allowed to use calculators. So how to solve it? You assume that this value is close to, very close to 8 into 12, which is very close to 96. Any value which is slightly less than 96 will be acceptable. So here if you see that only one value which is less than 96, which is 94.4, okay, so that will be our answer. Clear? Any doubt, ask me during the live doubt session, okay? Don't forget that. So here what is our strategy? Add the masses, then take the free body diagram, and in the free body diagram you always take the direction of acceleration is the rich direction, so rich minus poor equals to ma. Remember this, rich minus poor equals to ma. If you remember this one problem, you will be able to solve in KCET. A car is moving in a circular horizontal track of radius 10 meter with a constant speed of 10 meter per second. A bob is suspended from the roof of the car by a light wire of length 1 meter. The angle made by the wire with the vertical is. So here basically what happens, a car is rotating in a circular track, okay, and we are not drawing the car, by the way. We are not drawing the diagram of the car, but when you hang a string, what will happen? The string will make an angle with the horizontal to adjust the centripetal force. Okay, so if you hang something in a car and if you rotate in a circular path, the string itself will try to go away from the direction where your center is. Okay, so the rotation is, the center of the rotation is in this direction. Okay. What is the distance? Distance is 10 meters, so we will say that the car, the size of the car is negligible, so that this distance is also equals to 10 meter, right? 10 meter, yes. What is the velocity? Velocity is 10 meter per second. So what is the centripetal force? Centripetal force is mv square upon r. This is the centripetal force. This is the centripetal force which is acting on this small bob as well. Now, when you hang it like this, okay, there will be a tension acting on this string. Okay, if this angle is theta, then this angle will also be theta, alternate angle. Okay, these two are parallel. So that means if this angle is theta, then this angle will also be theta. Okay, so this tension has two components. Here T cos theta component, and here we have T sin theta component. Okay, so T sin theta, what is T sin theta? T sin theta is actually providing the required centripetal force, and T cos theta is actually balancing the weight of the object. T sin cos theta is balancing the weight of the object. So if you divide these two, what you will get? You will get sin theta, T sin theta by T cos theta equals to Fc by mg. Right? Basically, it's a resolution of vector problem. So you are resolving the tension into two components. One is along the motion, one is along the other direction of the weight. So this component is balancing the weight, this component is providing the required centripetal force. So T cancels and you get tan theta equals to mv square by r into mg. Cancels, so you get v square by rg. Some books use this as a formula. This is actually not a formula. You have to come across this formula by this way. So if you know this, draw this diagram, simply write this and simplify it. Okay, if you remember the formula, good. So what is tan theta then? Tan theta will be equals to, what is v? V is 10, so 10 square, 10 into 10. What is r? R is given 10 meters, and g we are assuming 10 meter per second square, so everything cancels, we get equals to 1. So theta equals to 45 degrees or pi by 4. So theta is pi by 4. Next question, A body of mass 10 kg is kept on a horizontal surface. The coefficient of kinetic friction between the body and the surface is 0.5. A horizontal force of 60 Newton is applied on the body. The resulting acceleration of the body. First of all, we have to, so only kinetic friction is given. Static friction is not given, so assuming that the object will move, so we have to calculate free body diagram. So the force that is acting on this is 60 Newton, and there is a force of friction which is given by F. What is F? Because it's kept flat horizontally, so the reactionary force will be exactly equals to mg. Okay, reactionary force will be exactly equals to mg, so F, or the frictional force, will be mu r, that is mu mg. Okay, here it is kinetic friction, so let me write mu k. Okay, so what is mu k? Mu k is 0.5. What is the mass? Mass is 10 kg, and g we are taking 10 as well. So we will get this as 50 Newton. So frictional force is 50 Newton. Okay, so this is 50 Newton. So what is the net force? So remember, to calculate the acceleration you need to find the net force. What is net force? Net force should be the applied force minus force of friction which is trying to drag it back. So total net force will be 10 Newton. Now you have to use the Newton's law, that is ma equals to 10 Newton. So a equals to 10 by m, which is 10 divided by 10. So it cancels, you get 1 meter per second square. Okay, mass is 10 kg, right? So it will be 1 meter per second square. Easy question. Next, a block of certain mass placed on a rough inclined plane, the angle between the plane and the horizontal is 30 degrees. The coefficient of static and kinetic friction between the block and the inclined plane are 0.6 and 0.5 respectively. Then the magnitude of the acceleration of the block is. Interesting question. Sometimes it can be tricky, but this is an easy question. So what we are going to teach you, I am going to teach you something new which I have not taught you in the theory class, which is called angle of repose. What is this? Okay, what is angle of repose? Angle of repose is basically an angle. If the inclined plane is kept less than that angle, the block will not move. If the angle is more than that angle, the block will move. Okay, so there is a concept in physics which says angle of repose. Now it can be solved in other way. Normal general you take the weight, you take the components, you solve it. That way it can be solved, but that will take a longer way to answer it. Okay, even though angle of repose directly is not part of the syllabus, but if you know this concept, you will be able. It was there in the syllabus. It is no longer part of the syllabus. But even if it is not there, you can still solve this question in normal mechanical way by taking the free body diagram of the object, right? But if you know this concept, this problem can be solved in seconds. First of all, here if you read the question carefully, there is a static kinetic friction, there is a kinetic friction, there is a static friction. Both kind of frictions are given. That means the object may move, it may not move. Okay, so if it is moving, then we have to find the acceleration. If it is not moving, acceleration will be 0. So how can we find the acceleration? So to find the acceleration, first of all, we have to find whether the object is moving or not. So to test that, we will use the concept of angle of repose. Now if the static friction is equals to tan theta, okay, up to this limit the object will not move. If the static friction is slightly more than this tan theta, this is called the critical case. Okay, critical angle, similar to that, this is the critical angle. At this angle the object will just start to move. Okay, if you push it slightly, it will start moving. But if the angle is less than this value, then the object will not at all move. So first of all, we will test whether this condition is satisfied or not. So what is tan theta? Here theta is given 30 degrees. So tan 30 is 1 by root 3. 1 by root 3 means 1 by 1.7, which will turn out to be 0.57. Okay, so the tan theta value here, the tan 30 value is less than the static friction. The tan theta value is less than the static friction. So in that case, the object will not move at all. Okay, the object will not move at all. If this value is greater than 0.6, then only the object will move. If it is exactly equal, it is the critical case, this case. Okay, and if the value is less than this value, it will not move at all. Okay, here tan theta is less than the static friction. It does not matter about the kinetic friction. Kinetic friction does not come into the picture until the object starts moving. So here, because the static friction value is more than that of the tan theta value, the object will not move, so the acceleration will be 0. So this is a trick question, but if you know this concept, you can answer it quickly. Now next, a wooden block of mass m lies on a rough floor. Another wooden block of the same mass is hanging from the point O through string as shown in the figure. To achieve equilibrium, the coefficient of static friction between the block on the floor with the floor itself is. So here, if you see the diagram, here we have two masses. Okay, here we have two masses, m and m. Okay, there is an angle theta. Now this block is at rest. To achieve equilibrium means whatever force of friction is acting on this block, the same force has to be acting on here. So frictional force must be equals to F. Now what is force of friction? Obviously mg is in this direction. The normal reaction is upward direction. Okay, and force of friction will be mu r, that is mu mg. So force of friction is sorted. Now we have to think about this force. What is this force? This force is actually coming because of this one. So this block is applying a force mg over here. So mg force is here. This mg force is actually gives rise to this tension, and because of this tension there are two components. One force is acting in this. Okay, if this angle is theta, this will be t cos theta, and this will be t sin theta. Okay, so t sin theta and t cos theta. So this force is F, this is t cos theta. You have to find basically the value of t, so that you can say, okay, this is the force which is acting on this object. So that means if these two forces are equal, then we can say that the object is at object must be in equilibrium. So first of all, what is force? Mu mg, and that should be equals to what? T cos theta, right? That must be t cos theta. Secondly, what? This force is acting downward, mg, t sin theta is acting upward, so mg equals to t sin theta. Okay, now what? You are trying to find the mu value, so just divide them, t cancels, and you get mg cancels, you get mu equals to cot theta. Okay, so if the value of mu is equals to cot theta, the system will remain in equilibrium. Okay, clear? A block of certain mass is placed on a rough floor. The coefficient of static and kinetic friction between the block and the floor are 0.4 and 0.25 respectively. A constant horizontal force of F is equal to 20 Newton acts on it, so that the velocity of the block varies with the according to the following graph. The mass of the block is nearly, take g as 10. So here velocity time graph is given. Okay, so if you see that this graph properly, here velocity time graph is given. That means what? The object is moving. Okay, the object is moving. Okay, so object is moving means what? which friction we need to consider? If object is moving, we only need to consider the kinetic friction. We do not need to consider the static friction at all, because from the graph we can see that object is not at rest, object is moving. So what is the kinetic friction? Again, because it's a horizontal object, we can say that the kinetic friction must be mu k mg. Okay, this is the kinetic friction. What is the applied force? Applied force is 20 Newton. So what is the net force? Net force is actually equals to the applied force minus the kinetic frictional force. Okay, so this is the net force. Now from here we can say that, okay, this is the net force, that means there will be an acceleration. So net force equals to ma. Net force equals to ma. So acceleration will be equals to F net minus m. Okay, or let's put the values 20 minus mu k mg by m, that is 20 by m minus mu k into g. We will put the value of mu k and g, but first of all we have to find out the acceleration from this graph. So velocity time graph is given. How to calculate the acceleration? To calculate acceleration, we have to check the slope of the graph. It's a straight line graph, so slope will be y by x. Okay, it will be y by x. What is y here? Y is 20. Okay, so this acceleration is 20 divided by 3. Velocity is increasing with time, straight line, so the acceleration is slope of the graph. How to calculate slope? You can take any differences, okay, but because these two are the known values, okay, you can take this one also, but here you do not know this value. You can take this also, but here also you do not know the value. So but this at the end of 3 seconds, this is a correct value 20, so that's why we are using this. Okay, so acceleration is 20 by 3, and that is equals to 20 by m minus m mu k. Mu k is 0.25 and g is 10. So it will be 20 by m minus 2.5. Okay, so we have calculated this. Now we can calculate the mass as well. So 20 by m equals to 2.5 plus 20 by 3. Okay, now this calculation can be tricky. Okay, just let me simplify this. How can we solve it quickly? Okay, so let's see, 327.5. okay, just simplify it. Now you can do the cross multiplication to find the value of m. So m will be equals to let me add a slide. Okay, so 20 by m equals to 2.5 plus 20 by 3. Now you might think, sir, there is a 20, can we cancel it? Do not do that. It is easier other way. So just take the LCM. 2.5 into 3 is 7.5 plus 20, which will be 27.5 by 3. Okay, now do the cross multiplication. So m will be equals to 20 into 3 divided by 27.5. Okay, so it will be 60 divided by 27.5. Now if this number is 30, if this number was 30, then our answer is very simple. It will be 2, right? So it means it will be 2 point some value. It will be slightly more than 2. Now if you go to our option, here you will see that only one such option is there, which is 2.2 kg. So definitely this is the correct answer. If you had a calculator, you could have calculated it 2.2 kg, but we do not have the calculator, so we have to guess. After this stage, how to guess the answer, that is also very important part of knowing KCET problems. So here 60 by 27.5, that means 60 very approximately 30, so 60 by 30, that will be equals to 2, right?